Hi everybody. So in this video, we're going to continue with dividing with decimals, but we're going to talk about dividing a decimal by a decimal. So now your denominator or your divisor is also a decimal. And we're actually going to find out that it's really quite confusing to try to do that. So what we do is we change the divisor into a whole number. But when we make that change, we also have to make a second change to counter it so that we get the correct answer. And we actually do this a lot in math. If you think back to our sign number rules, when we had subtraction, we changed it to addition, but then we also changed the sign of the following number. When we're working with fractions, when we had division, we changed to multiplication, but we flipped or took the reciprocal of the second number. So in mathematics, you will often see that we do make changes to make the problem easier to work with, but there's usually a second change you have to make as well to counter the first change so that they balance out. Even equations as well, right? When we add something on one side of the equation, we add it to the other side too. So we're going to see that here now. All right, so I think this is easiest to see really just with an example. So let's do an example here. So let's do 10 and 764 thousandths divided by 2 and 3/10. So the way this is set up is it's 2.3 is on the outside, and then the 10.764 is on the inside. And what I've said before is it's really hard to kind of think about, well, how many times does 2 and 3/10 go into 10, right? That 3/10 is really weird for us to work with for division. So what we want to do is we want to make this a whole number. And to do that, we're going to move the decimal point to the right. Okay. So I'm going to move it all the way to the end of the number. Here in this case, I happen to move it one place. And you make the same change on the inside. So if this is moved one place, I have to also move this one place as well. So what I'm actually going to end up dividing instead is 23 going into 107.64 or 64 hundredths. So this gets moved one place, this also gets moved one place. Basically what we're doing is we're actually, in this case, multiplying both of those numbers by 10 to start so that we clear out the decimal in the divisor. Because again, it's just kind of too complicated for us to try to think about. So this is the way that we divide with decimals in the divisor. We change them into whole numbers. And now we're going to do just our regular long division here. So 23 does not go into 1. 23 does not go into 10, but it does go into 107. So my guess here is it's going to be 4 or 5 times. I'm actually going to do my, let's move this up. I'll do my work over here. So I'm going to guess that it is, let's try 4 times first. And the reason I thought about 4 is because I know 25 times 4 is 100. So I thought, well, 23 times 4 will be close to that. So 4 times 3 is 12. Carry the 1, and then here I have 8 plus 1 is 9. So I have 92. That seems a little low. Let me try times 5. So 5 times 3 is 15. Carry the 1. Here I have 10 plus 1 is 11. So that's actually too big. So I'm going to use 4 here. So notice that I'm not really making a multiples list this time just because 23 is kind of a big number. I'm trying to use instead like a guess and check idea. But I am going to keep my work. I'm not going to erase this because this will help me later on if I do want to make a multiples list or just to try some other values. So it's going to be 4. And then I have 92. So 7 minus 2 is 5, and 10 minus 9 is 1. Now I bring down that 6, and what happens is this decimal point just goes straight up. So now I have 23 into 156. Well, I already know what times 5 is, so maybe I'll try times 6 times 7 and see if I can get in the ballpark here. So 6 times 3 is 18, carry the 1. That's 12 plus 1 is 13. That still seems like it could be too low. Let's try 7. 7 times 3 is 21. Then here I have 14 plus 2 is 16. So that's too big. So it looks like 6 is going to be the option here. And again, I'm not erasing my work because now I have some of my multiples going. So I'm just kind of keeping them as I go along. So I'm going to use the next one, which is 6. And that is going to be 138 I'm going to go ahead and here subtract, and I have 18. I'm going to bring down that 4. Now I have 184. Again, this looks a little bit small, so let's try times 8. I get 24 there. Here I have 16 plus 2 is 18, and I get exactly 184. So I know that 8 is going to work out perfectly here, and I will finally be done. So my answer here then is I can drop the leading 0, so it's just 4 and 68 hundredths. Let's do another example. All right, so I'm gonna do 17 and 5/10 divided by 48 hundredths, and then I'm gonna round to the nearest hundredth. So this tells me that the problem is probably not gonna end, or if it does, it ends really far out. So we're gonna end up rounding our answer here. So I have that 0.48 on the outside and that 17.5 on the inside. Remember, your second number always goes on the outside. It's not about how big or small it is. And what I'm gonna do here is I don't like this decimal. So I'm gonna move it 2 spots to the right, and I make the same change on the inside. 1, 2. Now here, I'm going to have to tag on a 0 to make that work. So my problem becomes 48 into 1750, and then here's my decimal point right there, right? It goes 2 spots over, so it becomes right here. And now I'm going to go ahead and start. So 48 does not go into 1, does not go into 17. It does go into 175. So 48 is almost 50. So 50 times 3 would be 150. So my guess here is maybe to try 3. So let's try that. So I get 4, carry the 2, so 12, 13, 14. And let's try 4 as well, just to see. Here I get 32. 16 plus 3 is 192. So that's too big. So it looks like 3 was right. I subtract here, and I get 31. And then I'm going to bring down this 0. So now I have 48 into 310. So again, 48 is kind of a hard number, so I don't feel like writing out a whole multiples list. So I'm just going to kind of use a guess and check idea. 48 is about 50, and 310 is around 300. So I'm guessing like 50 times 6 would be 300. So let me try times 6. There I get 48, and then here I have 24 plus 4 is 28. So that looks good. That looks pretty close. So I'm going to stick with 6 here. And do a little bit of borrowing to subtract. And I have 22. Now, I'm not done. It does say to round. This decimal is going to go straight up. So what I can do is I can attach a 0 here, and I can keep going. So I have 220. So it looks like it could be 4 or maybe 5. So again, I'm just going to keep my work. Don't erase your work. Students always erase their work, and then it's like you're redoing the same multiplication over and over again. So just leave it there. So here I have 24. So I see that that's too big. So the 4 is going to work here. I'm going to do my subtraction. I have 28. Now I'm not done. I'm going to bring down another 0. So now I have 280, and I already did 288, and I saw that that was too big, right? 288 is too big, so it must be 5 then. So this is going to be a 5 here. So I have the 240 already done. Subtract and get 40. Still not done. Let's attach another 0. So now I have 400. Now that's quite a large number, so I'm going to guess maybe times 9 or times 8, because that's much bigger than what I already have here of 240 and 288. So let's try times 9. 9 times 8 is 72. So here I have 36 plus 7, so that's going to be 43. That looks too big. So let's try 48 times 8. That's going to be 64. And then here I have 32 plus 6 is 38. So that looks good. All right, so now I see I'm still not done. And if I go back to the problem, it does say to round to the nearest hundredth. So remember that when you're dividing, just make sure you have enough decimal places. If I'm rounding to the nearest hundredth, I need one extra decimal place. And I have that here, right? Because the hundredths would be the 5 position. So I have to go out at least one more. If you go out more than that, that's fine. But you want to make sure you always have at least one more than what you're asked to round to. So I can stop here. And I'm going to use that 36.458, right? This is going to be an approximate answer. I'm rounding to the nearest hundredth. That 8 will end up bumping that 5 up. So my answer is about 36 and 46 hundredths here. Okay, so sometimes we don't finish, we may have to round. And again, you may have to attach zeros to keep the problem going, but that's okay too. Another thing we could do is we could also estimate to help us check. Now, you could also multiply this back out to check. I will warn you though that because it is not an exact answer, you won't exactly get that 17.5. You'll be very close to it though. So when you're checking your long division, if you have an approximate or rounded answer, when you multiply out to check, so if you did 36.46 times 0.48, you're going to get close to 17.5, but not exactly there. So just kind of a warning if you don't have an exact answer. But we can also estimate to check here. So for instance, let's go back to this problem here and let's go into my values after I changed over the decimal. So this was 48 into 1750. So when you're estimating, again, you have a little bit of wiggle room of how much you want to estimate. But usually we tend to like to estimate and just make your life easy. So I'm going to use just one digit here and then zeros. So the 48, if I think about rounding this to just having one digit, that 8 is going to bump that 4 up to 50. So I was kind of using 50 anyway as I was doing my division. And then if I think about the 1750 here, if I want to round to just that leading digit, well, this would become about 2,000. So if I do 50 into 2,000, and I think about my answer there, it's going to end up being 40 times because 5 times 4 is 20, and then you have the 2 zeros. So my estimate for my answer here is about 40, and we got 36.46. So that seems in the ballpark. That seems reasonable. So we can use estimation as well to check. And just remember that estimation is a little bit subjective. So if the question specifies how they want you to round, then you should do that. But otherwise, it's usually up to us. So some people may want to round this to just the leading digit, which is pretty common. Other people may want to be a little bit more specific. So maybe you want to round this to 1,800 instead and use 2 digits. And that's okay too. So we're just using it to get a ballpark answer to know what we should expect. I do also want to talk about a shortcut here as well. So dividing by powers of 10, so like 10, 100, 1,000, etc. And this is very similar to the multiplying one, but we're going to go in the opposite direction. So what you do is you move the decimal point to the left the same number of places as zeros in your power of 10. So for example, if I have 5 and 64 hundredths and I want to divide this by 1,000, I have 3 zeros. So I'm going to take this, actually let me rewrite it so I have a little bit more room here. And I'm going to move it 3 places to the left. 1, 2, 3. And then I'm going to fill in any holes with zeros. So my answer here is 0.00564. And again, you can always put an extra 0 for the whole number to be a little bit more specific. It also works with whole numbers, and that's because you do always have a decimal point, remember? So your decimal point is here on the right. So in this case, I have 1 0. So I'm just moving this one place to the left. So this one was 3. So my answer here is 4.8 or 4 and 8 tenths. And again, if you want to make this a negative instead, you can do that too. So the negative, it works the same way. The same rule also works if you were dividing by negative 10. You just would do your sign rules in addition. So let's say I had negative 48 divided by negative 10. It would still be the 4.8 step, and then negative divided by negative is a positive. So you could still apply your sign rules here as well. Let's also do a few examples with variables before we move on. So let's evaluate x divided by y for x equals 4.5 and y equals 0.05. So if I'm evaluating, I'm just plugging these numbers in. So I have 4.5 divided by 0.05. So if I set this up, that 0.05 goes on the outside and that 4.5 goes in on the inside. And remember that we don't like decimals on the outside. So I'm gonna move this 2 spots to the right and move this 2 spots to the right and fill in any holes. Now, some students who are comfortable would just do their work right on here, and that's fine. I personally like to rewrite this. This becomes a 5, and this becomes 450. My decimal would be there. So now 5 does not go into 4, but it goes into 45 9 times. Do be careful here, though. My decimal point is here. I do have to finish the problem. This is not just 45, it's 450. So you technically bring down that 0. 5 goes into 0 0 times. And now I've reached the decimal, I can stop. So my answer here is 90, not 9. So just be really careful there that you finish the problem and at least go all the way through the decimal. You can always attach extra zeros after the decimal, but you do need to go through the decimal for your division. Is 720 a solution to the equation y over 100 equals 7.2? So remember, if you're talking about solutions, you're just taking your value here. So this is our y value, and we're replacing it in the equation. And we're going to see if the answer is actually true. So I have 720 then over 100 is equal to 7.2, right? This is my question. Well, think about your rules here. We're doing 720 divided by 100. So I have 2 zeros. So I can take my decimal, which is here on the end, and I can move it 2 spots to the left. So this becomes 7.20. And we don't need that ending 0 because it's after the decimal point. So this just becomes 7.2. So we do get that 7.2 equals 7.2, which is true. So it is a solution. No. All right, and let's do one more example here. So let's say Professor Pollard is painting her living room, and she needs enough paint to cover 1,400 square feet. So first of all, how do I know how much paint I need? So what you would do, so for each of your walls, right, here's one of my walls in the room, we'll say. Let's say it was a 10-foot room by 8-foot high. Well, the area here is length times width, which we've seen before. So it would be 10 times 8, which is 80. So this wall alone would be 80 square feet. So I do that for all my walls, or maybe also my ceiling, and I add up all those dimensions. And that's how I can figure out how much square feet I'm trying to cover with it. Okay. Let's say a gallon of paint covers 250 square feet. How many gallons does she need? So we need 1,400 altogether. I know that each gallon of paint will only cover 250. So I'm taking this total and I'm breaking it into groups of 250. So I have division here. So what we're looking for is taking that 1,400 and dividing it into groups of 250, because that's how long a can of paint will last. So I have the 250 goes on the outside and the 1,400 goes on the inside. I will tell you a little shortcut here is that when you have zeros on the end, and again, this is whole numbers, not decimals, but whole numbers here, you have a 0 on each end, you can actually cancel them out, but you just do one at a time. So you have to pair them up. So technically you're dividing each of these numbers by 10 to start. And it's just going to make your problem a little bit easier. So now I can do 25 into 140. So just a little tip, if you haven't seen it for a long time, that you can cancel zeros when you're dividing on the end, but you just do them in pairs. All right, 25 does not go into 1. It does not go into 14. It does go into 140, and it should go in 5 times here. So 125, oh, sorry, 25 times 5 is 125. So I'm going to subtract here. I get 5 and 1. I'm going to put a decimal point, and I'm going to bring it down. I'm going to keep going here. So 25 times 6 will give you 150 exactly. You can try that one at home. So I see that I need 5.6 gallons of paint. Now, if we think about this realistically, you're not going to buy 0.6 gallons. They do have smaller sizes. So I will say if you are painting and you only need like a little bit more, then you may just want to get like a quart or something like that instead. But here, it doesn't hurt to have a little bit extra paint, particularly if you're making a mistake or you find you need like an extra coat on one section or something like that. So I would end up buying the 6 gallons of paint here at the store instead, right? I'm not going to ask for 5.6 gallons. I'm going to buy that 6 gallon in this case of paint. But like I said, in reality, if you only had maybe 5.1 gallons, then maybe you could just buy like an extra quart instead and not spend the money on the 4 gallon. So there's just one application that we can do with painting here. Actually, I want to just check something. Yeah, that looks good. All right. Hope you guys enjoyed that problem.